Hello everyone, my name is Salesh Divedi. I am responsible for product management and cloud development for Oracle's globally distributed database. Today we are going to talk about how we can build never down global scale multi-cloud applications with Oracle's globally distributed database. A distributed database is a database that stores data across multiple physical locations instead of one location. Each location stores a subset of data. The physical data distribution is hidden from the application. Oracle database became a distributed database in 2017 when the native database sharding was released. Today, it powers many critical distributed applications around the world, like mobile messaging, credit card fraud detection, global payment processing, personalized marketing, internet infrastructure, smart power meters, where you have more like Internet of Things like applications. Our customers are using Oracle's globally distributed database for some of the key use cases like always on databases, where we want to have a database which provides zero data loss and extremely fast failover across multiple data centers, regions, and even countries. Data residency and data sovereignty is another big use case where customers are adopting distributed database, user and device proximity to provide low latency to the end consumers, petabyte scale analytics, and hyperscale online transaction processing, where we are talking about petabytes of data, millions of transactions per second. An Oracle globally distributed database is a single logical database. Database is physically distributed across multiple databases, which we call as shards. Data in each shard is replicated for survivability. All shards can process application requests. This gives us an active-active architecture. Further, the data can be redistributed across shards, data centers, and region while the database is up and running. The distribution of data is hidden from the applications. Application requests that only need data from a single shard are transparently sent directly to that shard. Requests that need data from multiple shards are automatically split into multiple requests that are sent to the appropriate shard and committed atomically. Queries can be parallelized both within and across shards to implement a massively parallel processing architecture. This is the next generation of big data done right. Let's take a look at few customer examples. Data sovereignty is becoming mandatory in many countries. Here is an example of Reserve Bank of India's localization regulation, which states that the payment data must reside in India if both payer and payee are Indian entities. This is a showstopper for many global financial services companies that store data for all countries in a single database in a single region. The key observation here is that the data must be stored in India but can be accessed from anywhere. A large US bank's global payment application complied with Reserve Bank of India's data sovereignty regulation by using Oracle's globally distributed database. A single distributed database is deployed across US and India. India data stays in India and rest of the world data is stored in US. The highly complex application tier architecture did not need to be redundantly deployed in India and had to do minimal changes to comply with the regulation. This is the most cost-effective way of complying with data sovereignty requirements. Another customer example here is Blue Kite that scaled to millions of transactions per second with petabytes of data with Oracle globally distributed database. Blue Kite was a hyperscale workload on multi-petabyte database that required near instant response times. The application did 1 million transactions per second, 30 billion APIs called per day, with latency of 1.6 millisecond. It was deployed on 104 commodity servers, each with over 50 cores, which amounted to almost 5,408 cores for a single logical database. And if we add up the memory across all these servers, it was around 77.4 terabytes. The data was distributed across 3 data centers for scalability and survivability, where a replica was created in a different data center where the primary shard was. Another customer example is a large infrastructure provider that achieves petabyte scale analytics for their core financial application, which has high speed device data ingest. This allowed them to have a scalable, high performance platform for ingesting millions of records per day and have long running analytical and ad hoc queries on petabytes of data distributed across multiple shards with a massively parallel processing architecture. Another customer example here is a global credit card provider that met their never down requirement with Raft replication for payment processing. This enabled them to have an active application and data tier architecture across multiple data centers, and we are able to achieve less than 3 seconds of recovery time objective with zero recovery point objective in case of a node failure or a data center failure. Oracle has more data distribution method than any other distributed database. Matching the data distribution method to the needs of application is critical for a distributed database. Oracle supports value-based and system-managed data distribution. Value-based distributes the data by list or range, for example, a list of countries or ranges of phone numbers. Or a system-managed distributes the data by a consistent hash, for example, uniformly distribute my data using a customer ID or a device ID. Or composite data distribution that distributes data at 2 levels by using 2 different sharding methods with 2 different sharding keys. For example, first by range or list of value, for example, a country, and second by a hash, which could be something like a customer ID. Oracle also supports user-defined data distribution. This is used when the data requires special handling, such as queued data. For example, in case of a music streaming application, we can store the data for popular artists in their own shards and lump the smaller artists together in a separate shard. Oracle supports global data distribution. Smallish tables that are read mostly can be duplicated across all shards. This is used to avoid cross-shard queries and cross-shard referential integrity checks. This is also referred to as global tables, where certain tables are replicated across the globe across multiple regions worldwide. Oracle supports online addition and automated data redistribution across shards. To scale out or scale in, shards can be added or removed. Data across shards is automatically rebalanced with minimum data moment. This is an online operation and does not incur any downtime. Oracle has more replication methods than any other distributed database. Oracle introduced Raft-based replication for extreme survivability. This allows applications to achieve zero data loss and sub 3-second failover in case of a node outage, a data center outage, or a region outage. This is a new replication method that uses popular Raft quorum-based replication protocol. It provides automatic failover to a replica in under 3 seconds. It implements an active-active symmetric configuration, which means each shard accepts writes and read for a subset of data. And it delivers zero data loss using a high-performance synchronous replication across shards. Oracle also supports additional replication mechanisms like redo level replication using active data guard. This provides fastest performance, most complete SQL functionality, readable replicas, and simplest operation. Oracle also supports SQL level replication using Oracle Golden Gate technology that provides fastest failover, fully writable replicas, including conflict avoidance and resolution. Oracle has more shard deployment architecture than any other distributed database. Oracle shards can be deployed across on-premises, cloud, multiple clouds. You can choose the deployment option independently for each shard or country. It can further be optimized for scaling needs and cloud availability of each country. Oracle Globally Distributed Database is designed for AI application. AI vector search and RAG on globally distributed database is supported in 23 AI. Oracle Distributed Database adds hyperscale and data sovereignty to Oracle Database 23 AI vector search and retrieval augmented generation. It allows to create hyperscale vector indexes that enable very large vector indexes to be sharded and loaded in memory to satisfy latency performance of the requirements. Customers will be able to combine similarity search using AI vectors with search for business data about customers and products in a single distributed query. Oracle also brings natural language queries to globally distributed database. Oracle Database Select AI can translate natural language questions into SQL using AI large learning models. The SQL query is automatically routed to the appropriate country or shard by a globally distributed database. Oracle's globally distributed database is available as an autonomous service that adds autonomous management to eliminate the operational complexity of a distributed database and reduces cost. Oracle Globally Distributed Autonomous Database enables a serverless elastic autoscaling architecture that dramatically lowers the cost. Oracle Globally Distributed Database is also available on exascale infrastructure. It adds serverless architecture to independently scale compute and storage at a lower cost. Oracle also supports multi-cloud distributed database where the data could be distributed across multiple clouds and on-premises. This enables protection from cloud outages, enables data sovereignty, user and device proximity. So the key takeaways are that Oracle's globally distributed database is the most fully featured distributed database. It provides more data distribution, replication, and deployment choices than any other database. Its converged database architecture makes data sovereignty easy for modern applications that use multiple data types and workloads. Raft-based replication provides fast, quorum-based failover. It supports leading-edge AI such as vector search. Autonomous capabilities remove complexity and reduce cost. Exascale support reduces cost and provides elasticity. Multi-cloud gives customer deployment location choices. Oracle's globally distributed database gives us all the benefits of a distributed database without any compromises. So why settle for less? For more information, please visit the link below. Thank you for joining me today. I hope you go check out other Database World 25 sessions.